Thanks, everybody. It's great being here. I've got the chance to present at a couple of these conferences through the years. And it's always fun because each one is larger and more sophisticated than the last. And so it's a pleasure to be here today. So as John mentioned, I am going to talk a little bit about strategy development and specifically innovative and disruptive strategies. By disruptive strategies, what I mean are business strategies that disrupt the existing value network. So usually when we talk about strategy, we talk about the value chain or the profit pools. Most of day-to-day management and even a lot of what's called strategic management is really about how do we improve our positioning in the existing value network, how do we become more efficient in the existing value network, and so forth. And that's a lot of our practice, a lot of what management does in general, and there's a lot of application for simulation in that space. Today, though, I want to talk about a little different take that gets a lot of press, and that's the idea of how do we use simulation to understand what could happen or how we should choose to act when the value chain is going to be blown up. And I like to say, you know, if you're not thinking hard enough about this, I like to say, look, what investments are we going to make? What decisions are we going to take today for markets that may not exist today, they'll exist in the future, and business models that have never been tried? How do we sort that out? And so that's what I mean by disruptive strategy. There's a lot of evidence that this is hard to get right. A couple classic quotes. What did Ken Olsen miss? Well, I think that Ken Olsen missed the idea that as the cost of computing collapsed, that the applications for computing was going to explode. He had in his mind the mental model of how big computers were and didn't sort of think about how that future might be different. Bob Metcalf, I love that quote. I often wonder what was in his head when he thought about spectacular supernova. I mean, exactly what was the visual that he had? I don't know for sure. But what I think what he missed there was that as connectivity increased dramatically, that the value of that connectivity was going to explode. And then Steve Ballmer, I think that was maybe 2006. What did he miss there? I think what he missed was mobile, the value of mobility. And of course, we all know how that all played out. Now, I want to make it clear that thinking about disruptive strategy is different than, quote, predicting the future, because I would argue that nobody could have predicted the future of computing in 1977. I would argue that no one could have predicted the shape of the internet in 1995 and so forth. But what is important is not predicting the future, but thinking about how we create the future. So this is inherently a creative process. And we have to think about tools that support that creative process. So if we look at the tools that have historically been in our toolbox, there's three of those: qualitative scenario analysis, data-driven techniques, and spreadsheets. And we'll talk about each of those three in turn. Then I would argue that all of those fall short of what we need. Qualitative scenario analysis is very useful. There is tremendous success with the planning as learning concept. There's a lot of case history of success. This is a great technique to support ideation and start the process of creative development. But the problem with it is it's inherently qualitative. And it doesn't take the organization far enough down the road towards what investments they're going to have to make and to what degree they need to make that investment and over what time frame. So that's a great starting point, but it doesn't take us far enough down the road. By data-driven techniques, I mean things like various correlational techniques, statistical, machine learning, things like this. And these are all techniques that look for patterns in the historical data, and they try and project those forward and say something useful about the near future. But obviously, if we're talking about blowing up the existing value network, then the information about the past may have limited relevance in the future. So once again, this is a highly useful technique. It helps us understand where we're at. It helps us understand what might happen if in terms of momentum strategy, but it doesn't tell us anything, or at least not enough, about how we recreate the future. Because by definition, innovation means that the future is different than the past. So that brings us to everybody's favorite, which is the spreadsheet. And every time that we talk about strategy, almost inevitably someone says, why do I need simulation? I have a spreadsheet. And spreadsheets are very popular because, firstly, almost everybody can run one. Maybe not well, but let's face it, they think they can. They do provide a good amount of what-if capability, so that's a nice thing. Let's remember, they are were really invented, for financial analysis and financial reporting. So they work very well in that environment, so there's lots of great application for that. But here's the problem. All complex systems, all systems that we want to understand how they really behave, have feedback, they have nonlinearity, they have time delays, they have complex internal structure driven by consumer distributions and so forth. And spreadsheets simply don't capture enough of that structure. And the problem is that the quality of strategic thought, in my view, the quality of strategic thought is tightly coupled to the quality of the model that you can use to represent it. And what I observe is that if the model that the stakeholders, the leadership are using leave out big chunks of what's important about the future, then the quality of their decisions will be less. And if we're talking about things that fundamentally change our business, that's a big blind spot. So to kind of dig into this issue a little more, I want to draw from a very active internet conversation that's happened over the last couple of years about the market opportunity for car hailing or services, Uber specifically. And I want to look at a spreadsheet model that was presented on the website of Damodaran, who is a finance professor, who writes a great blog. I would highly recommend you look at it. The link's in here. And he did an analysis of the market opportunity for Uber. And that spreadsheet that he built, he put right on his website. It's a great website. And of course, as we all know, because I'm not going to embarrass you by making you raise your hand, but you've all written a business model and it has this line in it, right? The market opportunity is just the market size times the share we're going to get. Every business model's got that line. That's what it boils down to. You can say whatever else about it, but that's where it starts. Okay, so Damodaran did a good job, I think, of figuring out, coming up with a very plausible assessment of what that market size might look like. Used to hit, global taxi, limo service providers. He rolls it forward a little bit, comes up with a nice number. And then he does some reasoning around what share we might get, regulatory, competition, other factors, very good analysis, classic spreadsheet analysis, and he comes up with a market opportunity that peaks at $10 billion. That's the size of the market that you might address. Now, an alternative way of thinking about this was reflected in kind of a responsive blog. This blog is written by Bill Gurley, who is a venture capitalist and thinker, and I think has some association with Uber. And in his blog, he presented a different point of view. And that point of view is captured by the image here. And the first thing I want to point out to you, that is written on the back of a napkin. So right away, it has more integrity with me, all right? And it's written in, looks like cheap ballpoint pen. I love that. I mean, that's where the great ideas come from. A second thing I'd observe right away is there's a lot more variables in here. There's more than 2, all right? So that's very interesting. And thirdly, I would say there's some structure. Whenever I talk about simulation and systems, I say we care about system structure. And people say, what the hell is structure? Well, structure is not one line in a spreadsheet. Structure here reflects immediately the feedback process. By the way, you can get this image by following this link. And so he goes through a set of reasoning based on this feedback structure on the back of a napkin and comes up with an opportunity that's 25 times as large as the spreadsheet version. Now, I'm not going to say what's right or wrong, because I think those are both interesting viewpoints. And to any stakeholder, I would say you'd want to do it both ways. You'd really want to understand how to think about this from different perspectives. So let's dig into this. Now, that's obviously, the back of a napkin still leaves you with a qualitative model. That's not, someday we could figure out how to feed that napkin into a machine and build the simulation from it. Andre's working on that for the next version 8. But for now, we have to do that by hand. All right. And so let's just look at the picture we have here. So let's start with this central feedback loop that says more geographic coverage, faster pickups, more demand, more drivers, more coverage, and so forth. So we have that positive feedback process that drives that business forward. And then secondly, we have an accelerating loop that says that as I have lower downtime, which means more efficiencies, I have lower prices and more demand. So what's different about this? What this says is that these positive loops then generate a change in the addressable market that's completely unrepresented in a spreadsheet sort of approach. You never get there. Now, we have to point out that that's not a complete model by any stretch. It leaves out a lot of important growth limiting factors, but I think it does highlight the difference in thinking between a spreadsheet approach and a simulation approach. So with that, I want to switch gears. Now I'm going to quit bashing spreadsheets and start talking about simulation. And I'm going to talk just a little bit about how simulation models that are built to analyze this kind of strategy, kind of what their elements are. I can't show you a model like this. A lot of times they're not especially visual, but we can at least talk through the characteristics. And the one thing I would say, and I was having this conversation with one of the other presenters this morning, is they almost always couple a fairly detailed operational description of how this future system is going to operate with more what we call soft elements about adoption, about consumer dynamics, about choice, about value. And so combining those two aspects of things is very important, because that operational component is discrete event. If it's a transportation system, it's vehicles moving through streets. It's all that detailed, cool stuff. But that consumer choice, market dynamics, the impact of market share growth, of word of mouth, that's classic system dynamics. So one of the things that we have, those of us in this audience using AnyLogic, is we have a tool that allows us to couple those two things. And all the models of this ilk, they always have that hard operational component tied to kind of these more theoretical components. A second aspect of this is the uncertainty about the future. We are talking about creating a future that does not exist. And so there's no facts about the future, right? So there's a lot of uncertainty about how things are going to play out. Even with a lot of thought, it's a lot of uncertainty. So you have to have a system that captures that. Thirdly, we think about things on a longer time horizon than many simulation applications might. Typically, 5 or 10-year horizons in order to think about how a completely new business model will be adopted and play through. So you really have to think about that in terms of the design of the model. And then finally, because the search space, if you want to think about it, all these possible futures, trying to sort through all of that and then come to some specific recommendation that a board of directors or a chief executive or other stakeholders would accept is pretty tough, because that decision tree just becomes huge. So now I'm going to make the heroic leap. We figured out how to build that model. We build that simulation model in AnyLogic, but that's only the first step of the process. So if you're going to start to analyze that, you need to start thinking through, we think of it in 4 steps. Build the model first, and then we think about performance metrics. Actually, we think about it all the way through, but still we'll present it this way. So by performance metrics, we mean you need to think about what the drivers of the system are beyond financial reporting metrics. It's not enough to say, here's the cash flow and balance sheet you're going to get, although those are important. But you have to dig into this and say, how does that adoption process work? How does your asset yield work? Well, how does all the details behind that work? And those are the operational drivers. So we got to collect that data. And then we have to visualize these results in a way that this giant search space can be compressed. And then we have to look at it across multiple scenarios that we might choose from. So this is how we frame up that process. We start by building a set of policy alternatives. These are choices that we make, we the firm make, and it's only about things we control. So this is about the things that we control that we can choose. Secondly, we tally up the environmental assumptions. So these would be macroeconomic factors, maybe things about the sharing economy and other stuff. And then thirdly, we have to look at this comprehending randomness that may exist in the system, just as things get lucky and fall one way or the other. So we cross all of those elements together and build a strategy table, which typically for us is maybe 1,000 to 10,000 scenarios for each quote simulation run. And you're not going to evaluate 10,000 of those on your laptop adequately. So we're going to feed those into some sort of execution pipeline to allow us to analyze all of that. This is what this pipeline looks very often for us. Firstly, we put it into the cloud. So if you don't, because like I said, you're not going to do this on your laptop, you and your 5 or 10 other team members, you're just not going to get there. So we put it into the cloud. We start with a strategy table, which we'd implement. And sometimes it's just Excel, sometimes it's Python. Then we have some custom software that we build in Python or Java to sort of manage the loading of those scenarios into the simulation model. We have an AnyLogic simulation model. And that model then writes its results still in the cloud to some database. We try and export that data as granular level as possible. So to the extent it's practical, we try and write out very detailed agent level or very disaggregate data. And then we use some sort of analysis engine or engines to sort through that and collect that data to generate meaningful results. And we might use Alteryx, Python, R. In fact, we often would use all of those tools. Crunch that data down, and then finally we get something that we would visualize for the client. Now, there's tons of different ways to visualize these things. I just want to show you one, just to sort of see how different strategies can be compared. So this is a simple case. we might look at the range of outcomes for a single policy choice that we're going to make. And we can look at those across multiple performance metrics, but let's just say we're going to look at it against one, might be cumulative cash flow, different performance metrics, whatever you like. And we just capture that in a box and whisker representation, so we can see the range of results for a single simulation. And then we can compare those against all the different policy choices that we're willing to consider. So in this case, you get the stakeholder gets a pretty strong idea of the most likely results, which would be captured in the box part of this, and then what the outliers or edges of that might look like as they look at the whiskers. Now, we could start to compare strategies then when we look at it this way. Some strategies are just better. So in this case, I would say in all ways, I say it right there, the better strategy is better because the top whisker is higher, the lower whisker is better, and the median of that's improved. So I would always choose the better strategy. There's no trade-off. But sometimes stakeholders are concerned about robustness. What if things go badly? So this is a more robust strategy. The upside is less, so that's not good. But the downside is better. So if I were a stakeholder and I was concerned about downside risk, then this may be a more attractive strategy for us. The usual strategy case, though, looks more like this, where the upper whisker, and it might be, in this case, is compressed a little by chart, but the upper whisker may be off the charts. The upside potential is spectacular if things go your way. There is a downside. The downside's not as good as some other cases, but it gives me access to more upside. And so this is sort of the risk and regret. By choosing maybe the more robust strategy, I actually create a regret because I didn't get access to the upside. On the other hand, I didn't expose myself to as much downside. So there's lots of ways to look at it. That's one way. One question is, why don't we just use an optimizer and search through the space? We use the optimizer all the time for every development. But in terms of strategy selection, it doesn't get you there because you got too many trade-offs. There's too many qualitative trade-offs between what the objectives of the leadership really are. Okay, so just to wrap up, what we're interested in is simulating futures that are radically different than the past and thinking about what, as stakeholders, we can do to make sure we're well positioned in that we're creating that and controlling as much of that as we can and exploring all those options. And simulation is the only way to get there, in my view. I certainly would not trust a spreadsheet. And of course, it goes without saying, if you're going to try and build this kind of a model with all the different components that you have to have, with the extensibility that you have to have, well, AnyLogic's our tool. And that's the end of my prepared remarks.
Thanks, Lyle. That was really good. So my question here is, what happens if you want to look at more than one entity making these decisions? So you're in a multi-agent system where, like competition, for example, for product introduction. So not only do you have to figure out what you're going to do, but you want to figure out what your competitors are going to do. And so, I mean, is that just one more angle, or does it become a lot more complex than that?
Yeah. So the question, I think, if I can boil it down, is how do we handle competitive response, right? Okay. And so competitive response works its way into almost any model like this. And so, of course, there's a lot of uncertainty about how the competitors might. See if I can I go back here? Well, I can't go back to my chart. So, but in any case, there's a lot of uncertainty how they're going to respond. So what we try and do is put that in the environmental, that's an environmental variable, and then we would try and parameterize that in different ways. So we might have a point of view, to make it really simple, a strong response, no response, whatever. And so we would try and look at different competitive scenarios and see how they would play out.
Can you just tell us a little bit about the size of the team that developed this?
Okay.
And also the other question is, how you determine, obviously when you are defining your strategies, you are facing a combinatorial explosion. How you determine, because I did some simple experiments with simple strategies, and I found out that the point is synergy between combining multiple simple strategy, and the problem is combinatorial explosion. Can you elaborate a little bit on that too? Thank you.
Sure. So the size of the team is highly variable. I mean, of course, it depends on the project dramatically, but we would often have teams, we would have multiple sub-teams that would be more data science. Some of them would be data science driven. Some might be obviously more software driven. And some of the team is more simulation expertise. So typically we would have all three of those sort of categories of folk involved. Although frankly, in most cases, everybody has a lot of overlap, but still, that's kind of the way we think of it. The size of the team, I don't know, from maybe 3 to 12. I mean, it's just highly variable according to the project. And usually, because the project runs in phases, not everybody would be on it, all at the same time, right? It'd sort of be rolling on and off, depending on what needed to be done. So in terms of your combinatorial explosion, you're absolutely right. We spend a lot of time thinking through how to craft a strategy, and I didn't emphasize it in the presentation, but that pipeline, and I should have, I guess, the pipeline gets run over and over and over again. So it's an iterative process as we explore that space. And so we use a combination of optimization and mechanical search tools and that amazing human judgment concept to generate and craft a set of strategy alternatives that, and I always like to say it this way, these are things we'd be really willing to choose. Okay, and then across environmental variables, which is the list of things we're really willing to consider the future to have. Because sometimes you'll say, well, you want to consider the collapse of the EU? No, we don't want to consider that as part of this strategy. Okay, so you set it outside the box. And then, of course, Brexit happens, and then I don't know. But, okay, so it's an iterative process. And somewhere in the slides there, which I kind of rambled through, we sort of figured this out that typically we're running maybe 500,000 simulations in one project because we're running the pipeline over and over. We're looking at that whole search space, and we're sort of noodling our way forward in that space to find what makes sense.
When you look at those scenarios that you have with the wide whiskers, et cetera, do you have any techniques, or you use any techniques to try to figure out what it is that drives you to that top extreme? Since you're talking about just looking for disruptive, it looks like you could try to figure out, okay, which scenarios actually run there and which ones are...
Yeah, absolutely. So I don't know, can I go back? Oh, I can go back now. Okay. Okay, yeah, right here. So what you see here is that each of those whiskers is built up of individual simulations. I can't really point, I guess. But so when we're looking at why, so the way we actually plot these oftentimes is an overview with box and whisker, but then we'll go through with the stakeholders in the interesting cases. We'll look at the individual case that drove, what drove that upper whisker? What would have to happen? And then we would also look at it grouping by randomness. Randomness is random, we can't control it. So how much of this is just noise that we don't know about? And then, you know what I mean? So you can actually, the beauty of this is that's all built up out of individual simulation runs. And each individual simulation run is built up of a highly disaggregate data set. So if you see something, for example, it just doesn't make sense to you, you can drill all the way back into, well, what's the data element way back upstream that really generated that? And that's very time consuming. So an awful lot of these projects, there's an awful lot of time spent writing simulations, but there's a lot of time in this policy development, data analysis phase, and working through that whole pipeline of processing.
Yes, sir. When you did talk about evaluating the complex interactions among the system components, I was kind of thinking about the fact that there are the different levels, which as to maybe the macro level, where you look at the strategic planning, and then going into the granularity of the micro level details, where you're looking at the interaction. But then at some point, there's always the fact that the uncertainty can kind of spin off. I mean, how do you reconcile these different levels in trying to evaluate the complex interactions, as you've said? Thank you.
Right, so that's a great question. So I think the question is how do we reconcile the different points of view about the system? So firstly, the tool, inherent in this tool set is that some of the system wants to be captured as agent, and we can capture that as agent. So for example, one view of the system is the individual consumer. So maybe we'd use agent for that, and that would decision rule. And then other parts of the system maybe want to be more aggregate, or they want to have different components. So part of the answer is, because we have a large palette of tools here, I can choose the technique that I need to choose to make sure I have the appropriate level of fidelity. But there is also just a judgment call, and that is that if we sort of keep a context about the decision that we want to make, so there's a context about that decision that we're going to make, then there are some things that are simply not necessary to include in the model to make that decision. And so that's a little bit of the modeling art, right? That's the simulation modeling art, is to choose just the right amount of representation so everything that's important is captured, but nothing that's unimportant is captured. So that last part of it, I can't quite give you the rule for it, but that's the way we go through it. Wisdom, that's right.